Hi to everyone. My name is Dan-Marius. I am from Romania, from Gheorghe Asachi Technical University of Iași, and I am happy and honored to be here. In this presentation, I will show one practical application related to smart agriculture. The application was developed in the frame of the agriHoverGames challenge organized by Hackster, a competition in which I participated in all 3 years of occurrence. A competition in which I took first place twice and second place once. This application aimed to detect and classify diseases in a vineyard. This application is based on a UAV system that was specially developed. The main idea is that there is a growing need for food worldwide. And this need requires the development of high performances, high productivity and sustainable agriculture, which implies the introduction of new technology in each stage of plant development. However, many elements affect crop development, like the one presented on this slide. But one of the most important is the existence or not of the different type of diseases. In this project, I developed an intelligent system to assess healthiness of vines based on the characteristics resulting from the analysis of the vine leaves, such as texture, shape or color. The intelligent system presented here is able to detect 2 different diseases. The first one is blister mite, which is generated by a mite species infecting grape leaves. This disease is also a vector for other viruses that affect vines. The treatment for these diseases should be applied when the first mite appear. If they are allowed to develop, they will do so quickly, mainly because this mite has between 5 to 7 generations in a year. The second detected disease is grapevine leaf roll disease. This disease is one of the most important grapevine viral diseases affecting wine grapes worldwide. The main problem with grapevine leaf roll disease is that there are no ways to cure an infected vine, and there is no chemical control for grapevine leaf roll disease. Therefore, the only solution is to remove and destroy virus-infected vines. So, as a direct conclusions, the field survey and the detection of the grapevine leaf roll disease are the only valid approaches used up to this moment. The grapevine leaf roll disease is considered one of the most economical destructive grapevine virus diseases. There are many estimates of the economic cost worldwide. Some estimate loss range from 29,000 to 226,000 per hectare. In another estimate, the loss is up to 77% revenue decline. So, as a direct conclusion, this intelligence system is important because a timely diagnosis and accurate identification of the grape leaf diseases are decisive for controlling disease spread and ensuring the grape's healthy development. Moreover, the early detection of diseases will determine the use of pesticide only when necessary, with a positive impact on the environment. The UAV system developed was built based on the HoverGame drone kit, which is a professional development kit produced by NXP Semiconductors company. This kit contains all the required components needed to build a quadcopter, such as frame, motors and flight management unit. The system incorporates a D435i deep sensor to guide the drone through the rows of vines. For vines planted industrially with mechanized soil maintenance, there is a 2.2 up to 2.5 meter distance between the rows, so we have plenty of space to fly. The Google Coral camera was used for plant anomaly detection. The intelligent detection system is supported by IMX8M Plus development board carried over the entire vineyard by an NXP HoverGames drone. The development board also has a neural processing unit on which the deep neural network is executed in real time. What is important to mention here is that almost entire system is based on open source software and hardware. By starting with the flight management unit, going through the Nutix operating system, which is in my case the base for the running of the PX4 autopilot, the Mavlink protocol, the ground station, the robotic operating system and Linux operating system, which run on the companion computer, and so on. At the level of the IMX8M Plus, the functionalities were implemented using the support of Robotic Operating System version 2. Additionally, a 0MQ client application and 0MQ server were used for debugging the developed application in real time. The HoverGame drone can fly autonomously, but based on a radio control link, the ground control operator can take control of the drone, switching from the autonomous to the manual mode. By using a telemetry connection, it is possible to configure the flight path, supervise and change settings and parameters of the flight management unit, and in this mode to check the status of the HoverGames quadcopter while it is in the air. Communication between the flight management unit and the companion computer was done by using an UART connection. The components that implement the software part of the UAV drone were developed as a single ROS2 package having 4 nodes. All the communication and synchronization between nodes were done through topics. The detection system is based on the TensorFlow Lite model and runs on the health plant node. The detection system starts when the UAV is set in the off-board mode. The node takes note of this fact from the flight control node through the flight off-board topic, and in this mode the detection process starts. The health plant node published 2 topics related to the detection process: detect VTIS and detect lift roll. These 2 topics post the area of the lifts for each class detected. This publication of the affected lift area can be used to create a real-time map of the extent of the crop damage. The flight control mode is connected to the PX4 autopilot, being able to control the UAV. It is also able to know the status of the drone at each moment. This node can arm, disarm, take off, land, etc. the drone accordingly with the necessities resulting from the off-board control. The video broadcast node can subscribe to a specific image topic and stream the image to the 0MQ video server based on the Wi-Fi link. Mainly because in this project I want to detect only 2 types of leaves, and because these leaves do not belong to the categories on which classical deep learning networks were trained, like person, car, airplane, bus, train, and so on, I use the transfer learning paradigm. So I use the MobileNet deep neural network, which is widely used for image detection and recognition. This neural network already has trained layers that can identify different features, like outlines, curve, edge, etc. So I used all of this already embedded knowledge and I only retrain the last layer. But in order to train this layer, a new training database with images from the 2 classes was created. 80% of the images from the database were used for training and 20% for testing. For the image annotation, model selection accordingly to the desired accuracy, model training, model optimization for efficient neural processing unit execution, and model validation, I used EAQ environment. Following the training process, the detection performance was a little bit more than 86%. Okay. Keep in mind here that this project was a proof of concept. Thus, I was able to prove the functionality of this approach, and of course, it can be applied in the same way to assess the health of fruit trees, maize, rice, or any other plant based on the state of the leaves. In conclusion, the system presented is a fully functional one, being able to identify 2 widespread diseases in the vineyards. The solution shows the potential application of the intelligence system in solving practical issues faced by agriculture producers. Thank you very much for your attention.